Okay, let's do this one called finding the time given an exponential function with base e that models a real world situation. So right now we're dealing with continuous changing models, right? Because we have base e in the exponential. So let's read the problem. It's a real world situation. It says that a girl named Ashley places a bottle of water inside a cooler. And as the water cools, the temperature in degrees drops and is given by this function after t minutes, right? So this function is going to give us the temperature of the bottle of water after t minutes. So notice that there is a little difference between the formula we gave in the explanation and with the function we have in here. We have another number that is being added to the formula. So this is not necessary to understand like the whole problem or the whole situation, but remember that we said that 13 is the initial amount or initial temperature, in this case, of the bottle of water. Initial temperature of the bottle. And the number 7 is the temperature of the cooler. So that is not necessary for you to understand this, but I'm just, in other words, better. This is not necessary for you to solve this problem, but I'm giving you this information for you to understand it better. So what we're going to do in here is, well, the problem is that Ashley wants to drink the water when it reaches a temperature of 17 degrees. So she wants to drink the water at that temperature. So the question is, how many minutes should she leave the bottle inside the cooler? And what we're going to do is, I'm going to erase this one because we really don't need it. What we're going to do is replacing the information we have in the function. So we want the output of this thing to be 17. And what we want to know is at what time will that happen. So in here we have an equation just like the equations in the last week, an exponential equation. So we're going to solve it. I'm going to subtract 7 in both sides of the equation, and it will be 10 equals 13 times e to the minus 0.038 t. And then I'm going to subtract by 13 both sides of the equation, and it will be 10 divided by 13 equals e to the minus 0.038 times t. And then I'm going to take the natural logarithm in both sides of the equation. Let me fix this a little bit. I'm gonna move this guy a little bit to the right to make it look better. I'm going to take the natural logarithm in both sides of the equation because I want this to get canceled, the natural logarithm and the base e exponential. Remember that the same base cancels, same base from the logarithm and same base for the exponential. And then we have that the natural logarithm of 10 divided by 13 equals minus 0.038 t. And finally, I'm going to divide both sides of the equation by minus 0.038. So t equals the natural logarithm of 10 divided by 13 divided by minus 0.038. Okay, I'm going to use the calculator to know what that number is equal to. And then I'm going to round to the nearest tenth. Be careful with this. You have to, you do not round any intermediate computations. So we are going to write the whole expression we have in the calculator. So this is going to be the natural logarithm, what's that? Natural logarithm of 10 divided by 13. All of that divided by minus 0.038. And that is what that is equal to. Round up to the nearest tenth. So that is just going to be 6.9, right? So at 6.9 minutes, Ashley can take the bottle of water out of the cooler, and it will be at 17 degrees Celsius. Let me check that. All right.